We've got a tank containing a two-phase liquid vapor mixture of refrigerant 22 and a pressure of 10 bar. The mass of saturated liquid in this tank is 25 kilograms and the quality is 60%. We want to find the volume of the tank in cubic meters, and we want to find the fraction of the total volume occupied by that saturated vapor. Okay, so this is going to basically be a quality type problem. Now we have our pressure is at 10, and let's write all these things down. So pressure is at 10, our mass is 25, quality is 60%. Now remember, your quality tells you the percentage of vapor in your mixture. So we got 60% vapor in that mixture. We want to find volume and the fraction of that volume occupied by saturated vapor. The equation we are going to start with here is going to be V equals VF plus X times VG minus VF. This is a good equation because it's got quality in here. We want to find volume. This is specific volume, but we could still use it to find regular volume. So let's use this equation. Now what you're going to do is you're going to look up your information in your table. You can use the pressure of 10 bar, look in the saturated water table, you'll be able to find VF and VG values. VF is going to be 0.8352, that's one of those you need to divide by 1,000. Then you'll have plus 0.6 times VG, which is 0.0236, minus the VF number. Alright, so that's what you're going to have there. Now this is going to give you specific volume. So V then is going to give you 0.01449 cubic meters per kilogram. Now remember, this is your specific volume at the point where your quality is 60%. Now, we want to find regular volume, so we're going to have volume equals mass times specific volume. To find this, since we already have this, we need to have mass. So let's find mass next. Now, if you remember, we know the relationship that mass of the liquid over the total mass has to equal 1 minus the quality. That means we can solve this for M, and then that would just be mass of the liquid over 1 minus X. Plug in your values, you're going to get 25 over 1 minus 0.6. That gives you 62.5 kilograms. Now we have our mass, we can plug that into this equation here. So you'll have 62.5 kilograms times the V that we just found right here, like that. Notice kilograms goes away. That leaves us with 0.9056 cubic meters. And now what we're looking for, we already found our volume, now we want to find the fraction of the total volume occupied by the saturated vapor. To do that, let's look at this expression here. So quality is the mass of the vapor over the total mass. So we know that. That means we can write that 0.6 is going to be the mass of the vapor over 62.5, and then you can find the mass of the vapor. That gives us 37.5 kilograms. Now we have that. Alright, so we got this now, and what do you think we should do with that? Yep, we're going to use this volume equation. We're going to have volume of the vapor equals the mass of the vapor times Vg. Now why are we using Vg? Because that's the specific volume you have when quality is at 100%, so it's all vapor at that point. Okay, so we're going to take that mass of the vapor, multiply it by Vg, so 0.0236, And that is going to end up giving you, whoops, forgot the number, 0.855 cubic meters. Now with this, we can find the percentage or the fraction that we're looking for. All right, so we're going to take this number, put it over 0.0956, which was our volume. So this is volume of the vapor over the total volume. That gives you 0.977. So you could either put that answer, or in fraction or percentage, you could put 97.7%. So either one of those would be okay.